So for those of you who hate math, this exercise is here to torment you. This exercise is asking us to write a Boolean function that returns true or false depending on whether or not the triangle formed by three side lengths given to us by the function here, a, b, and c, these three floating point numbers, whether or not they form a right triangle. So a triangle that has a right angle. So if you hate math, then this problem is, like I said, here to torment you with that. So to even get started here, we need to know, how do you check to see if a triangle is a right angle? And the answer is use the Pythagorean theorem, right? So the Pythagorean theorem tells us that a triangle is always a right angle, is right angled if a squared, so the length of side A times itself, plus b squared, so the length of side B times itself, equals c squared, side C times itself, where C is the longest side of the triangle, or the hypotenuse, as we call it. So this is what we're testing for. Is a squared plus b squared equal to c squared? And if it is, the triangle's right angled. If it's not, the triangle is not right angled. Now, we get a little wrench thrown into our plan here, in that doing arithmetic, so adding floating point numbers together, doing arithmetic with them, is not always super accurate. Floating point numbers can get kind of funky, and we only have so much memory to deal with floating point numbers. So if they get super funky, we can have the computer start to truncate those numbers for us by accident, which can lead to floating point errors, and we don't want that to happen. So instead, kind of the best way to check to see whether or not two floating point numbers are basically the same as each other is using this little snippet they provide to us right here. And all this is doing is it's checking if the absolute value of x minus y, so using absolute value to test both positive and negative, whether or not it's a little bit more or a little bit less than 0. If that is less than 0.001, then it is basically the same number within three digits here of proximity, within 3 digits of closeness here. So that gets us, for our purposes here, pretty much good enough. If you wanted to be more accurate, you could add some extra zeros here, but again, if you go too far, you're still going to run across the same issues. But this will get us close enough for the purposes of this problem. So anytime we want to check to see whether or not two values are the same during this problem specifically, we'll want to use this. So, okay, what do we need to check? We need to check if a squared, so, oops, sorry, that's a times 2. I don't know why I had that written this way up here. This is what I actually meant. We have to make sure we're exponenting. So a squared, which is a times a, plus b squared, b times b, equals c squared. Nope. C squared. There we go. Unfortunately, this, as we said up here, is going to be a little bit funky. So what we actually want to do is we want to check whether or not the absolute value of this right here minus this over here. So make sure that we get all of our parentheses correct so that it actually functions correctly here. So we'll want to get all of these together and then subtract it from that. So if the square of a plus the square of b minus the square of c is pretty close to 0, then return, what is it? True. Else return false. So let's see if this works. I'm a little hesitant, but we'll see if it works. Yeah, so it passes. Great. There's probably a more explicit way to write this, or some easier way to do this. We could have stored, I don't know, side A as a variable, right, like this, and side B as a variable like this, side C as a variable like this. I wouldn't recommend doing this. This is wasting a lot of, I guess not a lot technically, but if you're doing this a lot, you're allocating a lot of variable space that isn't necessarily super useful. So in this case, side A plus side B minus side C. And then I can get rid of all these extra parentheses that might not have been even necessary in the first place, but whatever. So this should still theoretically work. Yeah, so it still works fine. This, I would say, is bad programming. It's maybe slightly more readable, but it uses like 3 times the memory space for variables. So it's not, I would say, a good version. I would say go ahead and just have the full problem with A exponented, B exponented, that sort of thing down in here. So let's look down here. In number 10, it's asking us to extend the above program so that the sides can be given to the function in any order. So this basically works the same way, right? And let me get rid of this extra junk here. And we'll just take this as it is, actually. So, and pass that right into here. Okay, so if we can take these in any order, it means that we need to figure out which side is the longest side. So that's the first thing we need to do, is figure out which side is the longest side. So we can do that nice and easy. We can see if A is greater than B and A is greater than C, then longest equals A. Else, and make sure you define longest outside of here, longest equals, and we can make it an empty string, or we should probably make it a number. There we go. Else if B is greater than A and B is greater than C, set the longest to C, or rather, else the longest equals C. And then we'll want to change this so that it is this going to work, Ryan? No, it's not. That's okay. We'll still do it. We'll have longest exponented over on this side, and then we need to have the remaining sides over here. Let's do it this way. So what we'll do is we'll copy and paste this inside of here. This is not as clean as it could be, and we'll take a look at what their answer is here. We'll take an answer, a look at what their answer is outside of this to see how they did it in the textbook. So so this one right here, test is if A is the longest, then first of all I need to make sure all this is indented correctly. Then test to see if B squared plus C squared minus A squared is less than that. Else, do the same thing, but replace the values so that B is the longest. So replace B here with A and A here with B. Else, that means C is the longest, and we can just have it the way we normally have it. Okay, so this should work. There we go, it passes. So that's how I did it here. If I spent a little bit more time thinking about this, I could have come up with a better way, but let's see what the answer they gave us here is. No, they do it the exact same way. They do it the exact same way, except they have it set to a variable here, and then just return that variable, which is a smarter way to do it. It's more concise. But otherwise, it functions basically exactly the same as this functions out here. So, as you see, there are a couple things that you can do here to make it more concise. We can just test this statement like this without having to do a separate if statement and set that to a variable, because what this is going to do when we set this to when we assign this to a variable, what it does is it tests this statement to see whether or not it returns true or false. So we can just have these here, and they return either true or false, and then we store that to the variable and return the variable. So it's a little bit more elegant way to do it. But obviously, either way works, and however you came up with it, as long as it gets passes as well, is also valid.